Our next example is another very simple container in C++ standard library, which is called a pair. So pair is a pair of two values of type 1 and type 2. So when you declare a pair, it needs to be parameterized by two types instead of one. For example, this pair right here is parameterized by two strings, so it's called stir. So this is a storage for two strings. When you create the object of time of this type, it will have two data elements, first and second. Okay, so these are not member functions. These are the actual public data members of the pair. So it's very straightforward, and here we just directly assign values to the pair. Okay, so another example is the pair that does not store two strings but stores two different data types, integer and string. So instr, okay, and here first is given the value of 1 and second is given the value of 1, which is a string, and the opposite as well. So we can use the constructor of the pair. If we know these values up front, we can just construct the pair by using the constructor syntax. Okay, so we just use constructor syntax like this, and we provide initial value for the string and initial value for the integer in this case. So once again, once initialized, of course it will retain the values. You can change them later if you'd like, but here it just demonstrates again that this condition should be true, that the first the string element of this stir int pair is 2, and the second element is set to 2. So in general, in mathematics, you can have a sequence of values, and also these values would be known as components. And each component could be different, could have its own unique type. In case of a pair, because it supports two different types, we can sometimes call it as dual tuple or duple. And that's just the idea of the pair. And there are only two public data members, first and second, as we have already seen in our previous example. Construction of pair can be done using the default constructor or the constructor that takes two elements. So let's make a demonstration of this. I can rename my previous main demo as main set, and then make a copy of it, and just copy our return statement. And right here, if I want to construct a pair, let's create a pair of an int and a double. Okay, so something like this, and int double, right? Int double, something like this. So this is our pair. And if now you want to assign a new value to this pair, what can be done is that we can do here, we can just repeat this data type, right? Repeat this data type and construct a temporary pair that can be derived from value, for instance, 1 to 3, comma 456.7, something like this, right? So this is an integer and a double. Okay, and then we can display both of these values as int double, which is the new value right here. We'll display first, and we then also display the second, like this. Okay, and we can insert a space in between okay, or a comma and space like this. Okay, so let's just run this tiny little example, but the idea is that you cannot just assign you know, you can assign individual first and second, but if you want to assign the entire pair, you have to construct a temporary object, which is kind of lengthy syntax here. But nevertheless, let's try this example and see how this works. Let me see, what is this error? Already has a body. Oh, I need to rename this to be our main function. Okay, let's build. And okay, so there, so this worked, right? So these two values were assigned to my pair, which initially the default constructor would of course construct it with 0 and 0. Let's just verify that initial construction result using the default constructor. Okay, so we rerun this the second time. First we build, and then we rerun this. You can see that the first time, so this works fine. And I prefer to use a different approach here, and just to demonstrate that it may be more convenient rather than using this you know, data type which was initially specified to create this pair of integer and a double value. Sometimes it's just easier to do this make pair. Okay, make pair, and use a function which will take two types. Okay, and make pair is a template function which will deduce the type of 1 to 3, which is of course an integer, and 4, 5, 6.7, which is of course a double, and should be able to generate this object for us. So I just find this to be just a mere convenience, that we don't have to every time remember specific data type, but those data types are actually known from these two types that we provide to construct a pair that we think would be the one that we need at this stage. So anyway, so these two things really are the same, but make pair is a very convenient helper function to just construct a pair from the two values right here. Now another experiment could be that we could also say that maybe we want to use two integers to construct a pair. So let's see if of course make pair has no idea that we're going to assign the result to integer and double pair, so it will construct a pair of two integers. So let's observe if the compiler will be friendly enough to convert basically. Actually, it's not the compiler, it's the constructor of the pair that needs to be able to deduce the fact that it can essentially promote this integer to a double and be able to assign it to a double. So let's try this. We'll save everything and build, and you can see that this also works. So we can do like 2 more times. Let's print all of these steps that we execute. So we should get 0 0, then 456.7, then 456, and yeah, and this is just a duplicate. Okay, so we'll try this. Okay, so see, this works. So it's possible for this, so there's some flexibility in which you can convert pairs of, for instance, two integers to a compatible pair of integer and a double. So you get the idea. There is some flexibility in conversions like this. So pairs can be very, very useful in a situation where you want to return more than one value from a function. Okay, so you know that C++ function is limited to returning only a single value. So sometimes you can return a pointer to some kind of data structure. You can actually return a vector of elements of certain kind. So of course you're returning multiple values from a function that way. But if you really need to return two values, pair is an extremely good choice for the return type. So right here we say let's do some calculation. So there's a function right here, and apparently it returns a pair of a boolean and a double value. Okay, and we call it result. So this is a pair. The result is a pair, and so we can check the first and say if first, apparently it may be set to true or false right here, and apparently true indicates something good. We say okay, let's do more work with the second result, right? So with this double. But otherwise, if first indicates right here indicates false, so the calculation return false in the first parameter, we may interpret it as an error. So it's just a nice use for pair, and there's really a lot of different uses for a pair container. It's just really nice, simple, very easy to use, and just can be very directly helpful when you're trying to program something that requires a use of two related values that you want to use uniformly at the same time.